Welcome back to yet another session of Target JEE Advanced brought to you by Byju's. Now in today's session, we are going to look at the chapter Permutations and Combinations. In this session, I will be analyzing the chapter from the JEE examination point of view, look at the concepts which are important in this chapter before moving on to the all-important questions. Now the questions from permutations and combinations are what makes this chapter a little more tricky. This chapter is always an Achilles heel to most of the students who prepare for the JEE examination because there are no preset formulae to solve questions of this chapter. You can solve n different types of question and then an n+1 kind of a question appears in the examination because there's no dearth of the type of questions that can come from this chapter in the examination. Also, this chapter is a favorite of the ones who set the examination question paper. This can be seen from the trends that were there in the JEE Main and Advanced examination in the past few years. So if you look at the JEE Main examination, every year starting 2013 until the recently concluded exams in 2019, one question has definitely come from the chapter on permutations and combinations. Only in the year 2014, there were no questions from PNC directly in the main examination. Well, the different sections that have been tested in the examination can be seen here in this table. So mostly they have tested concepts such as general arrangement and properties of combination in the main examination. When it comes to advanced examination, permutations and combinations is even more important because there have been years when multiple questions have come. So every year starting 2014 until 2018, one question has definitely been there. But then there have been years like 2014 when there were 2 questions and 2017 when there were 3 questions from permutations and combinations. These questions again were from different sections. 2014 the questions were from properties of combinations and multinomial theorem. 2015 we had a question again from multinomial theorem and repeated arrangement. 2016 was properties of combination. 17 because there were 3 questions, there was a general arrangement question, properties of combination and multinomial theorem, and 2018 it was a general arrangements question. So the questions which come are from mostly general arrangements or properties of combinations or multinomial theorem and repeated arrangements. Well, there are very few concepts in this chapter, so the questions have to come from these concepts. But knowing these concepts are not enough to solve the questions which come from this chapter. These questions tend to check your logical ability, your reasoning ability, your visualizing ability. So you must be able to think logically and visualize every question before you're able to solve them. Let me quickly take you through the concepts which are important from this chapter before we move on and look at the questions. Okay, now we are going to look at the concepts which are important from this chapter. Well, permutations and combinations is introduced for the first time in your grade 11. So the chapter begins on a very easy note. We understand the concepts of permutation. We look at the formula of permutation. Then we move on to combinations, look at the formula of combination, solve a few questions from permutations and combinations, and make sure that we properly understand to differentiate between permutation and combinations. So this is broadly covered in the topic which is called as general arrangement. We look at the fundamental principle of counting. We look at arrangements. We look at a little advanced concepts such as circular permutations under this broad section which is called as general arrangements. Then there are these specific concepts which are very important from the exam point of view. The first one is properties of combinations. Now there are a lot of properties of combinations and questions appear in the examination testing your understanding of these properties of combinations. What is more important is the properties of combinations have applications in binomial theorem. The chapter on binomial theorem heavily depends on combinations, and knowing these properties will really help you solve questions in that chapter as well. Then there are these advanced topics which are generally tested in the main examinations. These topics such as multinomial theorem, repeated arrangements and selection, all these are advanced topics and these are tested generally in the advanced examination. Of course, there is this niche concept of distributing objects into groups, which is again an advanced topic, never tested in the main examination, but sometimes it can be tested in the advanced examination. But if you see, there are very few concepts in this chapter, very few formulae to remember in this chapter. So this chapter in terms of the concepts, it's not a difficult chapter, but what makes this chapter difficult is, again, as I've mentioned before, the types of questions. There are no limitations to the types of questions that can come from here. So solve as many types of questions as possible and make sure that you're aware of the different types of questions that are on offer from this chapter. Solving any different type of question will not ensure that you will still be able to solve the question which comes in the examination, because any day a new variety of question can be created. So it's better that you're aware of the different types of questions, but most importantly, you must have this presence of mind to understand the question on the go and be able to solve it. I will show you some very interesting questions. We will start by looking at a very simple question and move on all the way to multinomial theorem in these questions which we solve from this chapter. So sit back and let's solve some questions and have fun with this chapter on permutations and combinations. So the first question that we're going to look at is quite a simple question. Let's try and understand how combinations work using this question. So in this question, we've been told that there is a question paper which comprises of 15 questions. Furthermore, this question paper has two sections. Section A contains 6 questions and section B contains 9 questions. Now, a student has to solve 8 of these questions, and it is mandatory that he attempts at least 3 questions from both the sections. So the objective of this question is to find out the number of ways in which a student can do this. It's a very straightforward question. We just need to find out the different cases in which this situation is possible. So a student has to solve a total of 8 questions with a minimum of 3 from each section. So then a student can choose 3 from the first section, 5 from the second, 4 from the first, 4 from the second, 5 from the first, and 3 from the second. These are the 3 different cases which are possible. Now let's try and find out the number of ways in which this can be done. So what are the number of ways in which a student can choose 3 questions from the first section and 5 questions from the second section? The first section has a total of 6 questions. So the number of ways in which it can be done is 63 ways, multiplied by, there are a total of 9 questions in the second section. So that's going to be multiplied by 9c, because he has to choose 5 questions. It's going to be a 5 there. So 63 into 9c, 5 ways are the ways in which a student can choose 3 questions from the first section and 5 from the second. Now the rest of it is pretty similar to this. When he's choosing 4 from each section, it's going to be 6c4 multiplied by 9c4, and then when it's the other way around, 5 from the first section, 3 from the second section, it's going to be 6c5 multiplied by 9c3. Well, now it's all about solving this. 6c3 is nothing but 6 into 5 into 4 divided by 1 into 2 into 3. 9c5 is 9c4, so 9c5 and 9c4 are exactly the same, so it can be written at 9 into 8 into 7 into 6 divided by 1 into 2 into 3 into 4. Similarly, for all the other combinations, you can simplify it and then solve it. You can cancel out all the common factors from all these things, and similarly you can arrive at the solution by cancelling out all these, simplifying all these numbers. So I have cancelled out all the common factors from the denominator and the numerator, and now let's try and solve this question. So upon trying and solving this, we will arrive at 20 times 126 from the first time, plus from the second term you will get 63 times 30, and the third term will simplify to give you 504. So if you simplify all these things, you are going to end up with the answer, which is 4,914. So the end of this question is just a lot of mathematical calculations, and you might go wrong if you are not very careful with that. The permutations and combinations part of this question is a very simple one. I've solved this question only to make you a little more aware of what combinations can do. Such questions rarely appear in the examination, to be honest. But yeah, in the main examination, sometimes such questions do come. But in the advanced, you can never expect a question that is as simple as this one. So let's look at a few more convoluted questions in the next section. Now in this question, we've been given an even number of n-sided polygon. So the number of sides in this polygon is always going to be even. We will have a quadrilateral or a hexagon or an octagon. We cannot have a triangle or a pentagon. So it's going to be always an even n-sided polygon. Now, furthermore, it has been told that alternate sides of this polygon has been colored blue and red. So if side 1 is blue, side 2 is red, 3 will be blue and 4 will be red if it's a quadrilateral. So that's how this polygon is being designed. It has different colors for alternate sides. Then we join the vertices of this polygon to form triangles. But what sort of triangles are formed? Such triangles are formed which have only one common side with the polygon, right? So we join the vertices, we form triangles such that the triangles formed and the polygon have just one side in common. That's a crucial bit of information that is important to solve this question. The objective is to find out the number of such triangles which can be formed with blue sides. So for any n-sided polygon, we have to find out the number of triangles which can be formed by joining the vertices such that the triangles and the polygon have just one common side, and we have to find out the number of such triangles which have one blue side. It's a very straightforward and simple question if you understand what has been told. So to join vertices of a polygon to form a triangle with just one common side, it is mandatory that you have to choose one of the sides of the polygon and not more. Just one side of the polygon has to be chosen. So an n-sided polygon has n sides. So you can choose one of the sides in n different ways, correct? Now, one of the sides would mean you've already got two vertices of the triangle. You need a third vertex of the triangle to complete the triangle. Now, how is this third vertex chosen? Well, the third vertex should be chosen in such a way that you form a triangle which has only one common side. Obviously, you cannot choose the two vertices which form the endpoints of this side that you already chosen. So two vertices are already ruled out. But in addition to that, you cannot choose two other vertices which are next to this side, because if you choose one of those two vertices, then the triangle and the polygon will have two common sides. Do you understand? The triangle and the polygon cannot have two common sides. So you cannot choose those two vertices which are adjacent to the side that you've already chosen. So now this means that you have a restriction on the number of vertices which you can choose, and that is the total number of vertices minus 4. So n into n minus 4, these are the number of triangles that can be formed out of an n-sided polygon with just one common side with the polygon. So if you actually consider the case of a quadrilateral, you have 0 polygons. In fact, you have 0 triangles with just one common side with the quadrilateral. You need a minimum of a hexagon for at least 1 or 2 triangles of this kind to be formed. But there is one more catch in this question. We do not need all these triangles. We only need those triangles which have one blue side. So we know that of all the sides of the polygon, half the number of sides are blue in color, half the number of sides are red in color. So we do not have the luxury to choose all n sides. We can only choose n by 2 number of sides. So the correct answer to this question is n by 2 times n minus 4. So the total number of triangles which can be formed out of an even n-sided polygon such that one side of the triangle and the polygon are common is n into n minus 4. But since this polygon is alternatively colored, if you want one of the colors to be one side of the triangle, then the total number of such triangles are n into n minus 4 divided by 2. The very simple question, such questions appear more and more in the main examination. It's all about your ability to visualize. Now, permutations and combinations is a chapter that a lot of students sometimes don't like, is because this chapter does not have preset formulae. It's all about visualizing the question and understanding the nitty-gritty details involved in the question. A very interesting question, and I hope you had fun solving this question. We will solve more such interesting questions. Now, the problem statement of this question is a little convoluted, so let's try and break it into a language that we can understand very well. So what has been told in this question is that a group contains 10 people. Okay, so there are 10 people in a group, and rumor spreads from one person to another in the group. So the recipient of the rumor is chosen at random. Suppose one of the people in the group decides to transmit a rumor that he has received to another person, then this other person can be anybody in the group, except for the person from whom that person has heard the rumor. So if, let's say, a person PN has heard a rumor from person PM, then he cannot transmit the rumor back to person PM, but can transmit it to any other person in the group. This is a crucial bit of information that you must understand. Now, there is a rumor that passed from one person to the another and went to a total of 5 people. From one person to another, it went to a total of 5 people. So this means the rumor traveled 4 times. So from the starting till the end, it traveled 4 times so that it has reached a total of 5 people. Now we need to find the number of ways in which this rumor spread to 5 people, such that the first recipient of the rumor did not receive it more than one time. So this means that there was another bit of information that we have to infer from the question, and that is the fact that a rumor can actually go back to a person, but not through the same person whom he has transmitted it to. If P1 transmitted to P2 and P2 to P3, then P3 can actually transmit it back to P1. That's a possibility. So we need to even account for that. So let's say a person P1 is the one who's initiating a rumor. So P1 to P2, okay, so P2 is the first recipient. P2 can transmit it to anyone. So let's say that goes to P3, but he cannot transmit it back to P1. From P3, it can go to a different person P4, not P2, but it can also come back to P1. Okay, remember this. And from that 4th person, whoever has got the 3rd recipient, from that 3rd recipient, it can go to P5 or it can go to P1, but you cannot go to P2. Remember, in this question, it should not go to the first recipient. P2 was the first recipient, so it cannot go to P2. So P4 can send it back to P1 or give it to P5. He cannot definitely give it to P3 because he cannot transmit it back to the person from whom he has received it. A tricky question. A very standard permutation combination question where there's a lot of element of confusion going on. So let's try and find out the number of ways in which this can be done. So P1 to P2, in how many ways can P1 send it to P2? Well, P1 can send it to P2 in 9 different ways, right? We can choose one of the 9 people in the group. So P1 can choose one of the 9 people in the group. Now P2 cannot send it back to P1 from whom he has heard the rumor, but can transmit it to the other 8 people. So P2 has 8 choices to transmit the rumor. Now P3 cannot give it back to P2, but can give it back to P1 because P3 doesn't know that P1 was the initiator of the rumor. So P3 also has 8 different ways in which he can choose whom to transmit the rumor on to. But what about P4? P4 has a further restriction. He cannot send it to P3, of course. So that would have meant that he had 8 people to whom he could have transmitted the rumor. But according to the question, the first recipient, P2, should receive it only once. So P4 cannot even send it back to P2. So P4 can send it to P1 or the other 6 people in front of him, which are P5, P6, P7, P8, P9 and P10, but cannot send it back to P3 from whom he received, or to P2 because that's an objective in this question. So 4th person has only 7 different people to whom he can transmit the rumor. So the total number of ways in which a rumor can be spread to 5 people, the first person being the initiator to the last person, such that the first recipient or the second person in this chain does not receive it more than once is 9 into 8 into 7. Well, 9 into 8 into 7, that's a number that you must always remember. That's 504. 504 into 8 is nothing but 4032. So the total number of ways in which this can happen is 4032 ways. The reason I said 9 into 8 into 7, you must remember, is because sometimes you have these questions which is 9 let's say you have 9c3 or something like this, wherein there's a 9 into 8 into 7 divided by 1 into 2 into 3. So it's better to remember 9 into 8 into 7 as 504. It help a lot in your competitive examinations. So this question was a very convoluted problem statement. As such, it was not a difficult question, but you needed really good visualizing abilities and your ability to infer certain hidden details from the questions. That's an important ability when it comes to solving permutations and combinations questions. So very fun question, and we will now move on to the next question. Now, this is a fun question because we are going to consider a mixed double competition. So in this mixed double game, we have to arrange 8 couples, but every time they have to be chosen in such a way that a husband and a wife is never in the same team. So a mixed double tournament for which 8 couples are available to choose from, such that no husband and wife are in the same team. So in how many ways can we do this is the objective of this question. So let's divide this question into number of possibilities and solve it. Now that's a rule that you must remember in permutations and combinations. You should always consider the small possibilities and then add them up. Divide and rule is the best way to conquer any permutation and combination question. So the first case that I'm going to consider is the case that no 2 couples play in the same game. Okay, so we have 4 people chosen, 2 men and 2 women, such that there are no 2 couples in these 4 men and women. So the men who are there are not the husbands of the 2 women, and the 2 women who are there are similarly not the wives of the 2 men who are playing. So if no 2 couples play in the same game, how many ways in which you can choose people? Well, I can choose any of the 2 men or 8C 2 ways, but then I cannot choose their wives. So I only have 6C2 ways of choosing the ladies. If I fix the ladies, then I could have chosen the men in the other way. So either way, it's the same situation. You choose 2 of one gender, and then make sure that you do not consider their spouses when you choose from the other gender. As simple as that. But is that it? Now there is one more trick here. Now suppose I have chosen man 1, man 2, women 3, woman 4, then I can actually form 2 different teams out of it. I can have man 1 with woman 3 and man 2 with woman 4 as one set of opponents, but I can also have man 1 paired with woman 4 and man 2 paired with woman 3 as another set of opponents. So for every selection, I can actually form 2 different pairs of opponents. So the total number of ways in which you can get teams when there are no 2 couples in the same game is 8C2 into 6C2 into 2. So that's one of the cases. The other case is that in the game there is 1 couple. So among the 2 men and the 2 women, 1 man and woman are husband and wife. In how many ways can this be done? Well, we have 8 couples, so we have to choose one of the couples. That can be done in 8C1 ways, correct? Then I have to choose one more man. Now I have 7 men, or let's say I have to choose one more woman, whatever it is, one of the genders. There are 7 each of the gender, so I choose one from that. That's going to be 7C1. And of the opposite gender, I cannot choose that person's spouse. If I've chosen a man already, I cannot choose that man's wife because I already have the couple, because this is a case where there's only 1 couple. So that's going to be 6C1 ways because I have 6 of the other gender to choose from. So 8C1 into 7C1 into 6C1. Now let's consider, are there multiple teams which are possible? I have man 1 and woman 1, let's say, and I have man 2 and woman 3. How can the teams be formed? The couple should not be the same team. So man 1 has to go with man 3 and man 2 has to go with woman 1. So there is no other teams which are possible. So there's only one team which is possible in this case, which is man 1 with woman 3 and woman 1 with man 2 in this case. So when you choose one couple to play in a game, then there is only one set of opponents or 2 teams which are possible. There are no combinations possible in that situation. Let's consider the last case being 2 couples are a part of a game. So now this is a very straightforward thing. If 2 couples are a part of the game, then the man has to play with the other man's wife and the other man has to play with this man's wife. There is no other combination possible. Again, one set of opponents or two teams are fixed. In how many ways can you choose two couples out of 8? Well, that is a very straightforward, simple 8C2 ways. So the final answer is the total number of ways in which you can choose men and women out of 8 couples, such that no husband and wife play in the same team of this mixed doubles event, is going to be 8C2 into 6C2 into 2 plus 8C1 into 7C1 into 6C1 plus 8C2 ways. Now 8C2 is nothing but 28. 8C is 8 into 7 into 6, that is going to be 336. And this is going to be a little more convoluted. It is going to be 8 into 7 divided by 2 multiplied by 6 into 5 divided by 2 multiplied by 2, which upon simplifying, you will end up getting a number which is going to be 840. So the total is 840 plus 336 plus 28. If you add all of them, you're going to end up with 1204. Now, what makes permutations and combinations question a little tricky is that, first of all, the problem statement is going to be tricky. Deciphering the information out of a problem statement and understanding what you have to solve for is also tricky. And then there are these calculations wherein you have a very high probability of going wrong. So be very careful when you attempt permutations and combinations questions. It is not just enough to get the theory of it correct and the steps of it correct. It's also important that you get the numerical value correct at the end, because this is not a subjective type of examination. It's a multiple choice type of examination, which means you need to get the correct number at the end of it. So make sure you don't commit silly mistakes in the calculations. Fun question and a very systematic way of arriving at the solution. In this question, we have to consider the different permutations of the word Bengaluru, Bengaluru. Now, the number of words in which vowels occur at even places is A. The number of words in which the word glue, Glue, occurs together is B. Okay, so in the permutation of Bengaluru, the number of words where the vowels occur in the even positions, that is A, and the number of words in which the word glue appear together is B. The objective is to find out A minus B. So Bengaluru, it's a word which has 9 different letters, Bengaluru, 9 letters, not 9 different letters, because U repeats. So it has 8 different letters, 7 unique ones, and U repeating 2 times. So there are 9 different places available to arrange the different letters of Bengaluru. Now there are 4 positions available for the vowels, right? If the vowels have to appear at the even positions, there are 4 different positions available for the vowels. How many vowels are there? Well, E is a vowel, A is a vowel, and the 2 U's are also vowels. So there are 4 places available wherein we have to arrange these 4 letters E, A, U and U, because U repeats. The number of ways in which it is going to happen is going to be 4 factorial divided by 2 factorial. Now there are 5 other places for the consonants. Well, these are the 5 places for the consonants, and none of the consonants repeat. So these 5 consonants can be permuted in 5 factorial number of ways. So 4 factorial divided by 2 factorial into 5 factorial. If you solve this, 4 into 3 into 5 factorial, 4 into 3 is 12, 12 into 120, which is 5 factorial, you get that A equal to 1440. Okay, so A is 1440. So now what is B? B is the number of words wherein the word glue appears together. Now GLUE is 1. Now we're going to consider that as one entity. Now this one entity can actually occupy how many places? Well, here are the total number of places that this one entity glue can occupy? Well, if you see, there are a total of 6 different positions that glue can take. So glue can take 6 different positions, and in the other 5 positions, if G, L, U and E are gone, so the G is gone, L is gone, U is gone, E is gone, then B, N, A and U and R, B, N, A, U and R, 5 other letters have 5 positions and none of them are repeating now. So they can be permuted in 5 factorial number of ways. So this is 6 into 5 factorial. 5 factorial is 120. 6 into that is 720. So B is equal to 720. We've already seen A was equal to 1440. So A minus B equal to 720. This is a very standard permutation combination question, a very interesting question, and such questions do appear in your main examinations very frequently. So practice many such questions. They will help you solve your board examination questions as well as JEE main questions, and of course they'll be a good practice for higher concepts of JEE Advanced examination. Now in this question, the information that is given to us is that there are 8 intermediate stations between 2 terminus. The objective is to find the number of ways in which a train can stop at 3 of these stations such that 2 of those 3 stations where it stops are consecutive stations. Interesting question. So now let's see the number of stations that are available. There are 8 different stations which are available, and we have to make sure that the train stops at 3 of these stations, but 2 of them have to be consecutive. So let's group. So 2 stations have to be together. If you consider the first 2 stations as the station where the train stops, then the train can stop at one of the 5 other stations, but not this station, right? So this is one way. Now, so there are 5 different possibilities if the train stops at the first 2 stations. What happens if the train stops at the next 2 stations? So if the train stops at the next 2 stations, well, then the train couldn't have stopped at the first station and cannot stop at the 4th station. So it cannot stop at the 1st and the 4th. So there are 4 different possibilities. So when the train stopped at the first 2 stations, there were 5 possibilities. When the train stopped at the second and the 3rd station, there are 4 possibilities. Okay. Now, what happens if the train were to stop at the 3rd and the 4th stations? Well, if the train were to stop at the 3rd and the 4th stations, then it can stop at the 1st, but it cannot stop at the 2nd. It cannot stop at the 5th. So this means that the train has again 4 different possibilities. Similarly, if you look at the other interior pair, then you will see that the train can have 4 other stations where it can stop. But if you consider the last one, the final 2 stops as the stations where the train stops, then it cannot stop only at the 6th station, but it can stop at any of the other 5 stations. So there are 5 possibilities if the train chooses the last 2 stations as the pair where it stops. So from this you see that for the extreme ends there are 5 possibilities, but for all the interiors there are only 4 possibilities. Well, if you see, there are a total of 5 interior pair of stations where the train can stop and 2 end point pairs where the train can stop. So the total number of ways in which this can happen will be nothing but 5 into 2, because there are 2 end pairs for which there are 5 possibilities, and then there are of course a total of 5 interior pair of stations. For this there are 4 possibilities. So there is going to be 5 into 2 plus 4 into 5. 5 into 2 is 10, 4 into 5 is 20. The total is 30. Now, there is a trick to solve this question in a different way, but that trick will not work unless you are very careful. You could have just considered one pair and all the other stations where it could have stopped. So there are a total of 7 pairs, and for each of these 7 pairs, there are 6 other stops where the train could have stopped. Correct? So a total of 7 into 6, which is equal to 42. But in all these cases, the problem is you're considering triplets where the train would have stopped, 3 consecutive stations where the train could have stopped. So you could have subtracted the triplets from this final answer of 42. If you consider the total number of pair of stations and then multiply it by 6, that is for each pair, one of the other 6 stations is where the train stops. And from that, if you would have subtracted the 6 triplets where the train could have stopped, you arrive at an answer of 36 and not 30. Which is correct? Is 30 correct or 36 correct? In fact, 30 is correct. We've seen very systematically that 30 is the correct answer. Then how is 36 wrong? Well, if you consider this exterior pair where the train stops at the station 1 and 2, and then if you consider all the other 6 possibilities, then you're considering the triplet 1, 2, 3. Okay, so you have to subtract that triplet 1, 2, 3. Then if you consider the second and the third station as the pair where the train stops, then you have to subtract 2 triplets. You have to subtract 1, 2, 3 triplet and 2, 3, 4 triplet. This means that from your calculation, you have to actually subtract the 1, 2, 3 triplet 2 times. Do you understand that? So you have to actually subtract the 6 triplet of stations which are available not once but twice. So from 42, if you subtract 6 twice, you arrive at 30, and 30 is the correct answer to this question. So the systematic approach of arriving at the solution, as I showed, is a better way, because there is a possibility that you might go wrong if you consider all the pairs with all the possibilities and then subtract the triplet of stations. It's a slightly tricky question, and make sure that you solve this question in a very systematic way. Now, in this passage type of question, the passage says that 15 identical jewels have to be distributed between P, Q, R, and S. So the first part of the passage question is that each one of P, Q, R, and S should get at least one jewelry. We have to find the number of ways in which this happens. Now, this is, to be very honest, a multinomial theorem question, but we have a small trick to solve this question. So if you have x plus y plus z equal to 10 and you have to find out x, y, and z to be non-negative integers, then we use this concept of balls and sticks. We take 10 balls and then we take 2 sticks to divide the balls into 3 groups, and that is how we solve this question. But that trick works if x, y, and z are non-negative integers in the case of xy plus z equal to 10, but does not work if x, y, and z can take a minimum value of 1 and not 0. So this case wherein P, Q, R, and S, well, the sum of P plus Q plus R plus S has to be 15 because there are 15. But P plus Q plus R plus S has a difficulty in solving it using the stick and ball method because P, Q, and R and S have to be minimum 1. So P plus Q plus R plus S equal to 15. We are going to convert this into a question wherein all the variables are non-negative integers and not positive integers, right? We're going to convert this question into the type of question that we know. And how do we do that? I'm going to write P as P minus 1, a new variable, plus Q minus 1, a new variable, plus R minus 1, a new variable, and S minus 1, a new variable. What happens to the right hand side? I have to subtract 1 4 times from the right hand side to get 11. Now my P, Q, R, and S minus 1s, these are my new variables x, y, z, and w. X plus y plus z plus w is 11, and here x, y, z, and w are all greater than 0. Now I can use the trick of balls and sticks, correct? I need 11 balls and I need to divide them into 4 groups, so I need a total of 3 sticks. So now a total of 14 positions are available because I have 11 balls and 3 sticks, and I have to put these 3 sticks to group them into 4 groups, and the number of ways in which I can put those 3 sticks is nothing but 14C3 because there are 14 positions available and I have to put the 3 sticks at 3 different positions. It is 14C3. So that is 14 into 13 into 12 divided by 2 into 3, which simplifies to 364. So did you see how I avoided using multinomial theorem to solve this question in a very simple way by making use of the trick that we already know? Because P, Q and R and S can take a minimum value of 1. I changed the variable into X, Y, Z and W, which were P minus 1, Q minus 1, R minus 1, S minus 1. Now I could use the trick wherein X, Y, Z and W are all non-negative integers. Moving on to the second part of this passage question. Well, the passage states that is 15 jewels have to be divided amongst P, Q, R and S. But now P can't have more than 5 jewels and Q should have at least 2 jewels is the problem statement. There is no condition on R and S and we have to find out the total number of ways in which this can be done. Now for this, we cannot avoid multinomial theorem. Well, this is a little convoluted and I am actually solving this question to tell you how convoluted multinomial theorem questions can be from permutations and combination and later on in probability. So let's go through this question in a very systematic way and arrive at the solution, because in the advanced examination such questions will appear. So now the total of P, Q, R and S is 15. So when we have a multinomial expansion, we are going to look at the coefficient of x power 15. But what is the multinomial expansion that we have to consider now? Well, now P. What is the condition on P? P can take a maximum of 5, correct? It cannot be more than 5. So you have to consider x0 plus x1 plus x2 plus x3 plus x4 plus x5. Remember, x is a value between 0 and 1. In fact, x is, in terms of probability, x would be the probability of success. So it will be x0 plus x1 plus x2 all the way until x to the power 5. This is going to be multiplied by all the possibilities of q. Now q has to be at least 2. So that is going to be x square plus x cube all the way till x power infinity, because then q has no restrictions on the upper bound. There is no upper bound for x there. For q there. Then we look at R and S. Now R and S have no lower bound or upper bound. So it's going to start with x0 plus x1 plus x2 all the way till x infinity. R and S. So that is going to be x0 plus x1 plus x2 all the way till x infinity whole squared. So this is the expansion that you have to consider. So now in this expansion, we have to find what is the coefficient of x to the power 15. That will be the total number of ways in which we can make sure that P can take a maximum of 5 jewels, Q gets a minimum of 12 jewels, and no restriction on R and S. x0 plus x1 plus x2 up till x power 5 is a GP, and this GP is interesting because x is a value less than 1. But of course, I can consider the first term to be equal to 1, the common ratio as x, and so the sum of this GP will be 1 minus x to the power 6 divided by 1 minus x, because there are a total of 6 terms there. Now, what about the second GP? The second GP starts with x square and it's an infinite GP with a common ratio less than 1. So the sum is going to be a divided by 1 minus r, x square divided by 1 minus x. Now the third one is also a GP. The first term is 1 and it's an infinite GP with a common ratio of x. So that's going to be 1 divided by 1 minus x. But because there is a square, the whole thing is going to be a square. So we need to find the coefficient of x power 15 in this. So now if I take the x square outside, then I have to find out the coefficient of x to the power 13 in 1 minus x to the power 6 multiplied by 1 minus x to the power minus 4. So that 1 minus x whole to the power minus 4. Now you have a binomial expansion with a negative coefficient. Remember, what is the binomial expansion for a negative coefficient? Well, this is the binomial expansion for a negative coefficient. So if you have 1 minus x to the power minus n, then you will see that all the terms will be positive because you will have a minus 1 raised to 2k. That is nothing but equal to 1. So you will have all the terms to be positive in 1 minus x to the power minus n. So you need the coefficient of x power 13 in this 1 minus x to the power 6 all multiplied by 1 minus x to the power minus 4 whole to the power minus 4. What are the different possibilities? Well, 1 can multiply x power 13 from the second expansion, or x power 6 can multiply x power 7 in the second expansion. So there are two possibilities. So let us consider what is the coefficient of x power 13 in the expansion of 1 minus x all to the power minus 4. Well, that coefficient will be nothing but 4 plus 13 minus 1 C13, which is nothing but 16 C13. 16 C13 can be simplified as 16 C3. The other possibility is when minus x to the power 6 multiplies x power 7. So we have to find the coefficient of x power 7. Coefficient of x power 7 in 1 minus x to the power minus 4 using the formula will be 4 plus 7 plus minus 1 C7, 10 C7. That simplifies to 10 C3. Okay, so the coefficient of x power 13 in 1 minus x to the power 6 multiplied by 1 minus x all to the power minus 4 is going to be 16 C3. That is when 1 multiplies x to the power 13, and when minus x to the power 6 multiplies x to the power 7, we get minus 10 C3. So the correct answer to this is 16 C3 minus 10 C3. Well, 16 C3 is 16 into 15 into 14 divided by 2 into 3, which is 6. Minus 10 C3, 10 into 9 into 8 divided by 6. Simplifying this, you will get the answer to be equal to 560 minus 120. So 560 minus 120. So the correct answer to this question is 440. It's a very tricky question, a very convoluted question. Multinomial theorem questions are not easy. So as far as possible, just like how we solved in the first part of this question, try and simplify the multinomial theorem question using the shortcut. But if that is not the case, as you saw in the second part of the passage, you will have to adhere to the standard procedure, which can be very tricky and convoluted. Just pray that such questions don't appear in the exam, because if they appear, you will have to sit and rigorously solve the question. Permutation and combination and in the future probability are definitely Achilles heels to most of the students. The reason is the concepts involved in this chapter are very simple, but the questions which come are really tricky. Now, there are no preset formulae to solve most of the questions. A lot of questions involve a little bit of common sense and a little bit of visualizing. That is where most of us go wrong, and we end up with not being able to solve the questions. Solving n number of questions are also not enough in this chapter, because anyone can come up with an n+1 different kind of a question. Just hope that the question which comes in the exam is the type of question that you've already seen before, or you are able to crack that question on the go. So permutation and combination is a chapter which is worth practicing a lot, because there are wide varieties of questions which are possible, and newer varieties come every year. So solve many different varieties of questions and be well prepared for the examination. If you have more queries on this chapter, you can write to us, or you can download Byju's The Learning app and look at the videos of permutation and combinations. I hope you had fun in this session. I will see you very soon with another session. Till then, have fun preparing for the JEE examination.
For more videos and live lectures on the JEE, click on the subscribe button now.